Watcher folks, today we're solving Blue Wigglers by krulltor. The rule set is as follows. Normal Sudoku rules apply. We have regional sum lines. Blue lines divide box borders into segments with equal sums. Different lines may have different sums. And Kropki. Digits separated by a black dot have a ratio of 1 to 2. If you want to give it a shot, hit the first link in the description. If you just want to see my solving attempt, let's dive in and unravel this. And the first thing that comes to my mind is that the minimum amount of digits we can put into 3 cells is 1, 2, and 3, which also already equals 6. So every regional sum line has one segment with at least 3 cells. So all these single cell segments are at least 6. But we do know on a black Kropki there can't be 7 or 9 because they don't have a valid double or half ratio. And this affects those 2 cells also, because this is the same number and this is the same number. Now we can put in the half ratio for 6 is 3 and for 8 is 4. If this is a 3 and we need to go to 6, we need 3 more, which is 1 and 2. That's a 4 and we need to go to 8. Those two needs to be 1 and 3. But a 1 is definitely in one of them. Let's see what we can put in here. Can be 1 and 2, 2 and 4. You can't put 4 and 8 in here because that would be already higher than 9. And we can't put 3 and 6 in here because 3 and 6 already is 9, but we need to add one more digit. So that's 1 or 2 and 4, but the 2 is definitely in there. And if that is 1 and 2, we have 3. We would need another 3 to add up to 6, 7, 8, or 9. And if it's 2 and 4, we are already at 6. So we would need a 1 to get to 7, 2 to get to 8. But 2 can't be in there because of this. Yeah. So not really restricted there. What else? Can we do something similar with this? Actually, yeah. 1, 2 is possible, 2, 4 is possible, but 4, 8 is not, and 3, 6 is not. I think that's valid for those two likewise. And they definitely have a 2 in them. Which means, let me double check on this one again. So can this be 4 and 8? Obviously not. It's more than 9. 3, 6 plus something is already more than 9. So yeah. But this 2 points into that 2. So the 2 actually is in here. No 2 in here. And 2 has like 1 as half and 4 as double ratio. So that is fine. Those 2's don't interfere with anything else. No. Okay, so that's a 2 and that's a 1. We are 3 and would need 3 in here for 6, 7, 8, or 9. If that's a 2 and that's a 4, we can add 1. Is it all the same? Also like with this. 1, 3, 4, 5, 6. Because 2 and 1, yeah. Okay, so that's the maximum amount of those is 6. Double ratio here again. But we have a 6-8 pair, so this cannot be a 6. Is this one the same as this? If we have a 3, we need to add up to 6, which is only possible with 1 and 2. If we have a 4, we need to add up to, so yeah, that is also true that the 1 is definitely in one of those cells. And maybe let's color a bit to make it more clear. Those are definitely not the same. And those are definitely not the same. We do get 2 into one of those. This cannot be 6 or 8 because of the pair. And if we have a 2 and a 1, we need 4 in here to get it to 7. And 6 to get to 9. If that's a 2 and a 4, we are already at 6. We need a 1 to get to 7. And a 3 to get to 9. Can't have the 1 in here because it's up here looking down. So 1 and 2 is 3. Now 2 and 4 is 6. With a 2, 4, you can't get to 7. Okay. What else? Mm. I wish that the 2 would do a little bit more for us. Oh yeah, actually it does. It looks down, this one looks up. So in here there is a 2. Going to the left, going to the left. So one of those is 2, giving us the 2 in. Yeah, we already knew that. One of those 2. Those. So where can it be in this box? It's not really restricted because we do have pencil marks on both sides and on top. but that does not really help. 1, 2, 4, and 1, 4 forms triple, which means if this is a 1, we have a 2, 4. If it's a 4, yeah. So this cannot be 1, 4, and this cannot be the 4. This actually is the 3, giving us a 6. 8, 8, 4. Let's get rid of a bit pencil marking. Put 4 in here. And I think we can get rid of the colors. Okay, so this is 8. We need no 2 in here. This is a 1, 3 pair. We already have 5, so this cannot be 4, 2, because then we would end up at 11. 4, 2 is 6, plus 5 is 11. So no 4 in here. That is a 1, 2 pair, giving us a 4 here. So this is 6. We can add a maximum 3 to get to 9. We can get to 8. Oh, that interact with this line, for instance. We do need 8 somewhere in here, but not really, right? Oh no, we do know this is 3 and 5 is 8. No 8 in here. Okay, so how about this? This is either 3 or 6. Okay. So that does not help for now. Okay, so maybe you can do something with Sudoku. We only got 1, 1, which is in those 3, those 6. 1 is on top here. It's not really help. 2 right hand side, still not very restricted in this box. Hasn't changed. Only 1, 3. Therefore, is 4 boxes here, 4 boxes, 4 cells here, 4 cells here. It gives us, so this 4 goes down. Those are already occupied, so the 4 in this box needs to be in here. So this cannot be a 4. This actually is a 1-2 pair. So that's 3. 3 and 3 is 6. 4 is 7 and 5 is 8. We can't have a 5 in there. And 6 is 9. Now this 4 going down, this 4 going down, this to the right. 4 is in one of those. We can say that 1 in this box, this one looks up, is in one of those. So it can't be in here. That's the 3. 3 and 6 is 9. No 9 in here. So 3 and 3 is 6 and 4 is 7, but can't have a 6 in here. One, 2, 3 is in one of those. 9 in one of those. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the rest is not worth pencil marking. Oh, this cannot be the one. So actually that's our one. We do a little bit more with the 8s. This row only has this and this as valid option. Right hand side. And one single 9 helps, maybe just a little bit, giving us pencil marks in here and on the bottom. Okay, am I missing something with the regional sums? Can this be 5? 5 and 3 is not possible. 5 and 6 is not possible. So this is not a 5. 1, 3, 1, 3 pair gives us 2 and 1 in here. 3, 1, add up to 8. Yeah, that's fine. That's 2, 1, 4, 4, 2 because of the black Kropki when we're missing it. Need a 2 in there. So that's 6. 6 and 3 equals 9. This is 7. So 3 and 2, 4, which is 6 equals 9. And 1, 2 is 6, so this can't be a 7. Nice. So we got almost all the regional sums finished, and we can do something with Sudoku finally. This now is a 2, 4, which equals 6, so this needs to be the 9. I think we got all the ones done. Let's check for 2s. 2, 2, 2. 2 in here, 2 in here. All the 2s are pencil marked. 3s. 1, 2, 3, 2, 3. This can't be 3, so that's our 3. Not in here, not in here, here. 4. Right hand side. Not as restricted. I'm moving on to 5. 6. I just want the easy ones now. 7 on the left hand side. And on this side. 8 in here. And 9. Okay. That was not as successful as I thought it would be. So let's check again. We got all the ones. We pencil marked all the 2s and 3s. So yeah, this 4 looks at this 1. So that's our 4. Going up, going up. So 4 is in either of those. And in here it has 3 options. 2 options in here. This one is ruled out by this pair. So it's in here. Here we're missing 5 and 7, right? This can't be the 7, so this way around. 5 and 6 to complete the box. This row needs 9 and 1, 2, 3, 4, 5, 6. Well, 6, 9. And to complete the box, we still need 1, 2, 3, 4, 5, 6, 7. And the 1 needs to be in here, right? Now we got all the ones, yeah. Okay. Let's check this box. 1, 2, 3, 4, 5. This is actually a 5-8 pair. And this therefore is a 7 and 6 pair. 1, 2, 3, 4, 5, 6. Oh no, I erased the 5s. 5 again. 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's do the same in this box. 1, 2, 3, 4, 5, 6, 7, 8, and 9 on the bottom rows. 1, 2, 3, 4, 5, 6 needs to be in here. Can't be in here because of this, so that's our 6. Giving us a 6 here, 4 here. 4 is wood out of this one. Let's put it also in this. Whoppa. We need benchmark 5, 8, 9, 1 to 5. So 5 is in one of those. Can't be in here. 5, 8 forms a pair, giving us a 7 in here. 6, 9 is a pair, so this won't be a 9. But this is the 9 for the column. In that row, we still need 7, 8. 7, 8. This needs to be the 7. So that's our 8. 5, 5, 8. That's 7, 9 pair. Let's put it like this. This is also 7, 8, 9. Only option is 8, so the 8 is ruled out of this one. 7, 9 pair here. Missing number in that box is 5. Now we got all the pencil markings done. This needs to be a 5, right? Yes. 5, 5. All the 5's done. 7, 7. 9, 9, 9. Just cleaning up the pencil markings we've done. And this is how we solve Blue Wiggler by krulltor. Thanks for the recommendation. I hope you enjoyed it and it helped you. See you around next time.